Okay, in this class I revise skeletal tissue, muscular tissue, nervous tissue. Now we discuss only PU examination point of view, not each and every point. We already discussed each and every point 1 month back. So now skeletal tissue. What is skeletal tissue? The connective tissue form the endoskeleton is known as skeletal tissue. Skeletal tissue classified into cartilage and bone. Cartilage and bone. Cartilage. Another name of cartilage, gristle. Another name is gristle, cartilage. Matrix of cartilage is semi-rigid. They may ask, write a short note on cartilage for 3 marks. Matrix of cartilage is semi-rigid. Semi-rigid means partially hard. Another name of cartilage, gristle. Like epithelial tissue, cartilage also avascular, means no blood vessels. Matrix. Matrix of cartilage known as chondrin. In the matrix, empty places are present. Empty places are known as lacuna. Each lacuna contains 2 to 4 chondrocytes. Each lacuna contains 2 to 4 chondrocytes. Fibrous layer present around the cartilage known as perichondrium. Perichondrium contains blood capillaries. The nutrients diffuses from the blood capillaries of perichondrium enter into chondrin. So cartilage depends upon perichondrium for its nourishment. So cartilage is the one of the skeletal tissue. Another name of cartilage, gristle. Matrix is semi-rigid. It has resistant against the compression. So cartilage has resistant against compression. It is avascular, no blood vessels. Cartilage is covered by not only here, I show only above the cartilage, actually a fibrous layer present around the cartilage known as perichondrium. Perichondrium contains numerous blood capillaries. The nutrients diffuses from the blood capillaries of perichondrium enter into chondrin. What is chondrin? Matrix of the cartilage known as chondrin. What are chondrocytes? The cells present in the lacunae known as chondrocytes. Simple definition. Chondrocytes are the cells present in the lacunae of cartilage known as chondrocytes. Active cells are chondroblast. Chondroblast cells secrete the matrix chondrin. So later they become inactive. Now they are known as chondrocytes. Chondrocytes enter into empty places. So enough few points. Types of cartilage also not mentioned in the textbook. So write a short note on cartilage. Cartilage is one of the skeletal tissue. Cartilage also known as gristle. Matrix is a semi-rigid. Cartilage is resistant against the compression. It is avascular. No blood vessels in the cartilage. Blood vessels present in the perichondrium. What is perichondrium? The fibrous layer present around the cartilage is known as perichondrium. Empty places present in the chondrium known as lacunae. Each lacuna contains 2 to 4 chondrocytes. In the matrix, collagen fiber bundles are present. Collagen fiber bundles are present. So in the textbook given, cartilage present as a endoskeleton in vertebrates. As the embryonic development progress, cartilage is replaced by bone. Example, tip of the nose, ear pinna, intervertebral discs. What are intervertebral discs? It is one vertebra, it is another vertebra. Every two vertebrae connected by a disc-like structure known as intervertebral disc. Intervertebral disc. For PU, it is enough. For competitive, we already discussed fibrous cartilage. Cartilage classified into 3 types: hyaline cartilage, elastic cartilage, fibrous cartilage. In the textbook, examples of different cartilage given. So, tip of the nose, hyaline cartilage, ear pinna, elastic cartilage, fibrous cartilage present in the intervertebral discs. Bone. Bone also known as osseous tissue. Matrix of bone is rigid. Rigid means hard. Another name of bone, osseous tissue. Bone has two connective tissue membrane. Outer connective tissue membrane is periosteum. Inner connective tissue membrane is known as endosteum. Matrix is present between periosteum and endosteum. Matrix is present between periosteum and endosteum. Long bone in children have 5 parts. So end of the bone epiphysis, next to epiphysis metaphysis, middle part of the bone diaphysis, epiphysis and metaphysis and epiphysis. 5 parts are epiphysis, metaphysis, diaphysis, metaphysis and epiphysis. What is epiphysis? Ends of the long bone epiphysis. Middle part is diaphysis. What is metaphysis? The part of the bone contain epiphyseal plate. Epiphyseal plate known as metaphysis. In children, during the growth, diaphysis grow toward the epiphysis. So what happens? Diaphysis increases, epiphyseal plate disappear. Finally, in adult, long bone contain only 3 parts: diaphysis, epiphysis, epiphysis. Means metaphysis disappear. Metaphysis disappear. The cavity encircled by endosteum is known as bone marrow or marrow cavity. The cavity encircled by endosteum is known as marrow cavity. Marrow cavity contain yellow bone marrow. Red bone marrow present in epiphysis and metaphysis. Red bone marrow present in epiphysis and metaphysis. Enough bone, also known as osseous tissue. Bone is one of the skeletal tissue. What is a skeletal tissue? The tissue form the endoskeleton. So what is endoskeleton? The hard part present inside the body and protect the inner delicate parts is known as endoskeleton. So bone is one of the skeletal tissues. Second point, another name of bone is known as osseous tissue. Matrix of bone is rigid, hard. Bone contain abundant amount of calcium phosphate. Calcium phosphate in the bone matrix. Bone is covered by 2 connective tissue membrane. Outer periosteum, inner endosteum. Between periosteum and endosteum, matrix is present. End of the long bone epiphysis. The part of the bone contain epiphyseal plate is known as metaphysis. Middle part of the bone is diaphysis. Metaphysis present only in the long bones of children. In adult, long bone contain only 3 parts: epiphysis, diaphysis and epiphysis. During the growth in children, the diaphysis grow towards the epiphysis. As a result, metaphysis disappear. What is metaphysis? The part of the bone contain epiphyseal plate. What is epiphyseal plate? That is a hyaline cartilage. Nothing but hyaline cartilage. The cavity encircled by endosteum is known as marrow cavity. Marrow cavity contain yellow bone marrow. Function of yellow bone marrow: store the food material, adipose tissue only. Red bone marrow present in epiphysis and metaphysis. In children, in adult, red bone marrow present only in epiphysis. Function of red bone marrow: red bone marrow contain several types of blood cells. They produce the daughter cells. So stem cells, ancestral cell produce several types of daughter cells known as stem cells. Stem cells present in the red bone marrow. The stem cell produce blood cells known as hemopoietic stem cell. Hemopoietic stem cell, HPSC, hemopoietic stem cell. So red bone marrow produce different types of blood cells: erythrocytes, leukocytes, thrombocytes or blood platelets. Enough with the help of diagram, you can easily explain few points. Bone. Now we discuss muscular tissue. You should know cellular components of blood. Another possible question. Blood is an example for fluid tissue. Blood contains plasma. 55% of blood is plasma. 45% of blood is blood corpuscles. So, another possible question. Mention the cellular components of blood. Corpuscles means cells. So, blood contains three types of cells. Erythrocytes. Erythro means red, also known as red blood corpuscles. Erythrocytes. Leukocytes. Leuko means white. Leukocytes. White blood corpuscles. Thrombocytes are blood platelets. Thrombocytes are blood platelets. These are the three types of cells. Truly, blood platelets are not the cells. They are fragments or bits of megalokaryocytes. Megalokaryocytes are cells present in the bone marrow. It divides into several bits. Each bit is known as blood platelet. So, blood platelets are enucleated without nucleus. In human being, erythrocytes also without nucleus. In human being, both erythrocytes and blood platelets are without nucleus. You already know leukocytes. Leukocytes again two types, granulocytes and agranulocytes. Another possible question, cellular components of blood. So, blood contains three types of blood corpuscle. Erythrocytes, leukocytes, blood platelets. Muscular tissue. Muscles are about 40 to 50% of total body weight. Muscular tissue. Muscle. Each muscle contains several fibers parallel to the longitudinal axis. They are known as muscle cells. Each muscle cell contains several fibers parallel to the longitudinal axis. Myofibrils. Each muscle cell contains several fibers parallel to the longitudinal axis. Myofibrils. Each myofibril contains two types of myofilaments. Myosin and actin myofilaments. Myosin myofilaments. Actin myofilaments. whatever may be the muscle, each muscle contains several fibers parallel to the longitudinal axis known as muscle cell or muscle fiber. Muscle cell or muscle fiber one and the same. Each muscle fiber contains several fibers parallel to the longitudinal axis. They are known as myofibril. In striated muscle and cardiac muscle, each myofibril contain two types of filaments alternately, myosin myofilaments and actin myofilaments. In case of smooth muscle, myosin and actin myofilaments are present side by side. Myosin and actin filaments are present side by side. That's why no striation. Striation means line. For example, it is one myosin, it is one myofilament, it is another myofilament. In this manner, each muscle cell contain several myofibrils. It is a muscle cell. Muscle cell contain myofibril. Myofibril. Each one is a myofibril. In each myofibril or in all myofibrils, in a particular area, myosin myofilaments coincide and appear as a line. So in this manner, myosin myofilaments are present alternately. It is one line. Later actin, again myosin. So myosin myofilaments act as a line. It is not mean that muscle cell contain only 3 myofibril. I drew only 3. Several myofibril present from one end to another end. In all myofibril, myofilament coincide and appear as a line. That's why they are known as striated. Striation means line. Cardiac muscle also striated muscle. Skeletal muscle, striated voluntary muscle, voluntary under the control of will of organism. Cardiac muscle, striated involuntary muscle. So cardiac muscle not under the control of will of organism. Now we discuss striated muscle, unstriated or smooth muscle and cardiac muscle. striated muscle. Striated muscle contain numerous striated muscle cells. It is one muscle cell. Striated muscles are cylindrical and elongated, like chalk, cylindrical and elongated. Connective tissue membrane present around the striated muscle cell is known as sarcolemma. Cytoplasm of the muscle cell is known as sarcoplasm. Mitochondria of the muscle cell known as sarcosome. Just below the sarcolemma, several nuclei are present. Means striated muscle cell is multinucleate. Multinucleate. Several cells. Multinucleate. Several nuclei are present. If several nuclei present in a cell known as multinucleate or syncytial state, this condition is known as syncytial state. Why several nuclei present in the striated muscle cell? In embryonic stage, several myoblast cells unite. As a result, one striated muscle cell is formed. So cytoplasm mixes, but nuclei never fuses. So that's why several nuclei present just below the sarcolemma. So few points. Striated muscle. Striated muscle contain numerous striated muscle cells. Striated muscle cells are cylindrical, elongated. The striated muscles, also known as skeletal muscles. The striated muscles, also known as skeletal muscles. Why striated muscles, also known as skeletal muscle? Striated muscles attaches to bone. That's why they are known as skeletal muscles. The striated muscles responsible for locomotion. The striated muscles undergo rapid contraction and relaxation. That's why striated muscles undergo fatigue. Fatigue means great tiredness. They undergo rapid contraction and relaxation. That's why they undergo fatigue. Fatigue means great tiredness. So they need rest. After working, they need some rest. Then only they are capable to undergo contraction and relaxation. The muscles undergo fatigue, only striated muscle. What is fatigue? Great tiredness. These points enough for PU. Striated muscle contains striated muscle cell. Striated muscle cells are cylindrical. Just below the sarcolemma, or you may write what is sarcolemma. The connective tissue membrane lying the striated muscle cell is known as sarcolemma. Just below the sarcolemma, several nuclei are present. That's why striated muscle cell is syncytial state. Syncytial state means multinucleate. Striated muscle also known as a skeletal muscle. Why striated muscle also known as skeletal muscle? All striated muscles attaches to bone. That's why striated muscles also known as skeletal muscle, except tongue muscles. Tongue muscles not attaches to any bone. Striated muscles undergo rapid contraction relaxation. That's why they subjected to fatigue. What is fatigue? Great tiredness. Next one, smooth muscle. Smooth muscle contains several smooth muscle cells. Each muscle cell is fusiform, means spindle shape. Fusiform, spindle shape. Anterior and posterior parts are pointed. Middle region is broad. Smooth muscle cells are uninucleate. Only one nucleus is present. We already discussed why they are known as smooth muscle. In the myofibril of smooth muscle cell, myosin and actin myofilaments are present side by side. That's why striations not appear, lines not appear. For example, here it is a striated muscle. Myofibril contain myosin filaments and actin filaments. All myosin filaments coincide and appear as a line, striation. Number of striations depends upon number of A bands. What is A band? The part of the myofibril contain myosin myofilaments A band. So the part of the myosin filament contain actin filaments I band. So number of lines depends upon number of A band. It is A band, A band, A band, A band. So in this diagram 4 lines appear. So in this the striated muscle cell given in this diagram has 4 lines. So number of striation depends upon number of A bands. So no need to write all these points for PU. You write few points enough. Striated muscle contain numerous striated muscle cell. Striated muscle cell is cylindrical, elongated. Striated muscle cells are multinucleate, several nuclei are present. Striated muscle attaches to bone. That's why striated muscle, also known as a skeletal muscle. Striated muscles undergo rapid contraction and relaxation. That's why they are subjected to fatigue. Fatigue means great tiredness. Next one, smooth muscle. Smooth muscle contain numerous smooth muscle cells. Smooth muscle cells are fusiform or spindle shaped. Striations not appear. That's why it got the name smooth muscle. Smooth muscles are present in the visceral organ, blood vessels, alimentary canal. So in various organs. So these muscles are present in visceral organ. What is viscera? Organ present in the coelom known as visceral organ. So smooth muscles are present in visceral organ. That's why smooth muscles also known as visceral muscles. Visceral muscles. Smooth muscles also known as visceral muscles. The visceral muscles undergo slow and prolonged contraction. The muscles undergo slow and prolonged contraction, smooth muscles. That's why they never subjected to fatigue. They never subjected to fatigue, great tiredness. So striated muscles are under the control of will of organism. So striated muscles are voluntary muscles. Voluntary, under the control of organism. If you want, we can walk. If you want, we can sit or stand at any time. So striated muscles are voluntary muscles. Smooth muscles are involuntary muscles. They are not under the control of will of organism. Once again, smooth muscle. Smooth muscle contain several smooth muscle cells. Smooth muscle cells are fusiform. Fusiform means a spindle shape. Anterior, posterior, pointed. Middle region is broad. Each smooth muscle cell contain one nucleus, uninucleate. In the myofibrils of smooth muscle cell, myosin myofilaments and actin myofilaments are present side by side. Next point, smooth muscles are present in visceral organ. That's why smooth muscles also known as visceral muscles. What are visceral organ? Organs present in the coelom known as visceral organs. The smooth muscles undergo slow and prolonged contraction. That's why smooth muscles never undergo fatigue. Only one muscle undergo fatigue, that is striated muscle. Next one, cardiac muscle. In structure, cardiac muscle resemble like striated muscle. In function, cardiac muscle resemble like smooth muscle. Cardiac muscle, it is a muscle, contain muscle cell. It is one cardiac muscle cell, it is another cardiac muscle cell. Cardiac muscle cells are cylindrical, but they are short. In case of striated muscle cell is cylindrical and elongated. Cylindrical, short. Two unique characters of cardiac muscle. Each muscle cell has branch and intercalated disc. With the help of branch, one muscle cell connected to adjacent muscle cell. What is the function of intercalated disc? Intercalated disc also known as communication junction. So convey the wave of contraction from one end to another end of the muscle cell. Due to presence of intercalated disc and branches of cardiac muscle, the wave of contraction quickly spread from one end to another end of the cardiac muscle. So intercalated disc and branches of cardiac muscle cell boost the wave of contraction. Cardiac muscle cell is uninucleate or binucleate. Means some cardiac muscle cells contain only one nucleus, some cardiac muscle cells contain two nuclei. Observe striated muscle, several nuclei. Striated muscle cell, several nuclei. Smooth muscle cell contain only one nucleus. Cardiac muscle cell, it is a cell. Cardiac muscle cell contain one or two nuclei. Next point is the cardiac muscle undergo rhythmic contractions. Rhythmic contraction. The part of the cardiac muscle where wave of contraction generate known as pacemaker. So generation of action potential is intrinsic, means neither nervous system nor endocrine system initiate the heartbeat, but nervous system and endocrine system may increase or decrease the heartbeat. So initiation of heartbeat is intrinsically regulated. So that means cardiac muscles is responsible for generation of heartbeat. The special type of cardiac muscle present in the special type of cardiac muscle cell that is known as SA node. SA node act as a pacemaker. What is pacemaker? The part of, so for PU all these points no need. So you have to explain in the structural peculiarities and function. So once again, cardiac muscle present in the wall of heart location. Second point, cardiac muscle is intermediate between striated and unstriated or smooth muscles. Third point, cardiac muscle in structure resemble like striated, in function resemble like unstriated. Fourth point, cardiac muscle cell has two unique characters. Each cardiac muscle cell has branch. The branch arising from cardiac muscle cell connected to adjacent cardiac muscle cell. Another point is presence of intercalated disc. What are intercalated disc? So it is nothing but extension of sarcolemma from one end to another end of the muscle cell. What is the use of intercalated disc and branches of cardiac muscle cell? Intercalated disc and branch convey the wave of contraction quickly from one end to another end of the cardiac muscle. Next point, cardiac muscle cell contain one or two nuclei. Another point, cardiac muscle undergo rhythmic contractions and relaxation. So cardiac muscle work tirelessly from birth until death. So in examination they may ask any two types of muscle. So describe striated and smooth muscle or smooth muscle and cardiac muscle. So you have to explain 6 or 7 points of each muscle. So structure, function, unique characters. Now we discuss neural tissue, also known as nervous tissue. Neural tissue also known as nervous tissue. Neural tissue contain two types of cells, neurons and neuroglial cells. Neural tissue contain two types of cells, neurons neuroglial cells, neurons and neuroglial cells. Neurons are responsible for receiving the information and transfer the information from one neuron to another neuron. You all know sensory neuron carry information to brain from receptor. Motor neuron carry message from brain to target organ. What about neuroglial cells? Neuroglial cells never perform any function of nervous tissue or neural tissue. Function is support and protect the neurons. More than 50% cells in neural tissue are neuroglial cells. What are the units of neural tissue? Maybe one more question. Units of neural tissue. Neurons are the units of neural tissue. Neuroglial cells. Neuroglial cells are more than 50% of total cells in neural tissue. They protect the neurons. Similarly, in dense connective tissue, two types, dense regular, dense irregular. They may ask, distinguish between dense regular, dense irregular. Dense regular connective tissue, dense irregular. Dense connective tissue, dense regular and dense irregular. What is dense regular? Collagen fiber bundles. Fibers are arranged parallelly. The dense connective tissue in which fibers are arranged parallelly known as dense regular connective tissue. The dense connective tissue in which fibers are arranged in different directions known as dense irregular connective tissue. The dense connective tissue in which fibers are arranged parallelly known as dense regular. The dense connective tissue in which fibers are arranged in different directions known as dense irregular connective tissue. Dense regular connective tissue is of two types, tendon and ligament. Tendon and ligament. Sometimes they may ask, define tendon. Tendon is a dense regular connective tissue, connect muscle to bone. Or distinguish between tendon and ligament. Tendon is a dense regular connective tissue, connect muscle to bone. Ligament is a dense regular connective tissue, connect bone to bone. Both are dense regular connective tissue only. So tendon is a dense regular connective tissue, connect muscle to bone. Ligament is a dense regular connective tissue, connect bone to bone. So in animal tissue, possible 5 marks question may be describe various types of epithelial tissue, one, or another may be explain striated cardiac or cardiac and visceral. They may give any two of the muscles. So my suggestion is you have to read with the help of diagrams. You can easily remember the concepts. So tomorrow I continue the animal kingdom.